Hello, this is Shravan. This is my video demo for Game 470 Assignment 4, and let's get right to it. I'll try to run through this really quickly. So the first one is just us building a shader class that does all the matrix mults on the CPU and then sends the data to the GPU. So, alright, so we get this pretty green cube. So the shader just has one matrix stored the product and one for the color. Everything else is the same. Shader color optimize similarly has a structure where the product is just stored in one matrix and you have the color. And finally, in the CPP, you have a method saying send object data, which takes all three of them, multiplies them, and then updates the constant buffer in the shader. And so this is where it's happening in draw scene, and that's it. And so we get this nice, really ugly green matrix. Yeah. All right. So this is the second one. Here we had to render about 5 objects and we had to minimize the number of matrix multiplications. So the shader is exactly the same. The only difference is that we have in the shader color class, we have a constant that stores the multiplication of the view and projection matrices. So, all right, there you go. 1, 2, 3, 4, 5. Yeah. So you have mViewProj, which just stores the whenever we yeah, right here. So send object world data. This multiplies it with the product that we have. Send cam matrices computes this product. So now when we do it just once in draw scene, we have the product computed. Now the world matrix, which is different of course, is multiplied, but this multiplication is done just the once. So that's that. The next one we have is the pyramid textures. So this is pretty straightforward. You just have to set the UVs appropriately and get the faces. And there's one slide, I don't know if it even qualifies as an optimization, but I'll just go over it. So I could have, there you go. So this is exactly the same, right? This is what we needed. We have the same texture being mapped to all the 4 sides and to the bottom, if I can get that. Yeah, there you go. So there is one thing that I could have done. I could have had more vertices for this maybe, because we needed all the 6 triangles, but 2 of these vertices, namely 2 and 3, we already have the UVs also right where we want them, so we don't really need to create more vertices with the exact same UVs. So that's why there's a few, then we have 11 instead of say 15 or 18, depending on how we want to create the triangle. But we already have that, so we don't need to specify them again. This one is the cube faces, and it's, well, actually it's pretty much the same as the earlier problem. The only thing is that for me, figuring this out took a little more time because I got really caught up in the handedness. So I really sort of am glad I did this question, because it really sort of cleared up stuff about the handedness and what's going on. Anyway, here we go. Blue, red, forward, top, left, and bottom right here. So that's that. Then for this one, this was where we had to what was this again? Oh shoot, I think it skipped ahead. Yeah, it skipped ahead. 1 second. Really sorry about that. I think this is the one that I have to run. So over here it's exactly the same, but we had to encapsulate and create a new class called shader texture. So the header file is pretty much what we already had from the assignment description, but we have data structures for the view projection matrices and one for the world matrix. So this is where it's actually happening. When you send cam matrices is again pretty much the same. This is all dealing with texture.hlsl, so you have that. You have the input layout being done in the constructor. You have the constant buffers being made here, and and send cam matrices, send world is pretty much the same, and set to context is again just how it's done normally. So in the set texture resource and sampler, the only thing that you do is when you get a shader passed in, you take that shader, that texture, and you sort of attach it to the same context that you have. So that's what's happening here. This is not that one. I think I have a couple of them running or something. Yeah. So yeah, it's probably not very smart of me to have done that. But here you go. So exact same crate face that we have in the xapp.cpp, but now we have the shader texture classes doing all that work for us. So now on to the further work. We have the unit box set over here, and I played around with all the three textures. This is what happens when we do that. You have brown, red, and white cubes. The reason why is that when you set it to unit box, you're not really setting the U and V, so U and V are 0 by default. So if you take a look at the respective textures, 0, 0 for the crate would be right here. This is why you get brown. 0, 0 for your 512 is right here. So you have a red boundary around this, which is why we have a red cube. And similarly for the cube faces texture, 0, 0 corresponds to a white region, which is why we have a white cube. Oh, man. And finally, the performance tests. Well, so I did a couple of them. We have one where we're basically using shader color and being pretty like not optimal, I guess. And let me just get right to it. Yeah, all right. So we have this, and then we create all those matrices and the world matrices and everything, and so we are updating and sending the data each frame. And then as you can see with the commented out stuff, we're using the optimized shader. We're sending the world data, world matrix data just once, and sorry, the camera matrix data just once and the world matrix data later on. But basically the numbers they look something like this. So as you can see, there's a definite difference in the frame rate. We've got about an improvement of nearly 20 to 25 frames per second. But like it was mentioned in the slides, it's not much of an improvement because there's like a lot of other stuff involved that's going on. And, you know, we still, I don't know, I guess we have a lot of stuff to do and there's a lot of variables involved. So that's it. I hope that was quick. It was last time was sort of a disaster. So anyway, thank you so much for watching and until next time. Bye bye.